My question for you from yesterday is like, who can remind us, let's say somebody maybe wasn't here yesterday, not yesterday, Monday, my bad. Who can remind us what we learned about on Monday? We learned about rigid transformations. Sam, remind us all. Yeah, they're all mad because I paused. Remind us all what we did on Monday.
Oh, so we learned about rigid formations and how, like, if they, how they keep the same, they stay the same size.
So the notes that we should have from Monday are that rigid transformations preserve size. So we talked about transformations. Sorry, transformation is all of them. Rigid is the kind that preserves the size. But then translation was the first one we talked about. Can anyone tell me what the nickname of a translation might be, Jude? Oh yeah, slide. Because we're going to get funky. And we can slide to the left. And you can slide to the right. No, sit down. So, like DJ Casper, don't make me, like, not do that in future class. Like, let me keep doing this. You got to be able to come back together. So we talked about translations. Then we also started talking about rotations. What was the nickname for rotation, Elias?
Well, spin, but can I tell you something about the...
You have 20 seconds, sure.
So, if you present your screen...
No.
Okay. If you go to Google and look up Cha-Cha Slide...
No. Moving on. I won't do anything without knowing what is going to happen. I'm moving on because I have a class to teach. So we also talked about rotations, which Elias said spin or turn. Like, those are the nicknames there. So now we're getting into reflections. Has anyone figured out potentially a nickname for reflection yet? Cora? I don't know, you guys maybe did, but apparently on this paper I didn't. What's another word? There's an M word a lot of you keep trying to use. Just shout it out.
Mirror.
Yeah, so it works like a mirror, right? Except the weird thing about a reflection, or about like a mirror, unless you've looked into how magicians do certain tricks, you normally wouldn't have a mirror like through your knees, or like straight up and down through your body, right? Yeah. But like with reflections and geometry, you can draw the line to reflect across through a shape. So, for example, in slide 5, which we're all going to go look at together, we got to use random cards, because why wouldn't we? Michael, can you tell me one of these that will work, that will get my pre-image to land on my image? Thanks, Sam. Much appreciated. I don't know how you guys hadn't yet thought, hey, he was showing us notes. When I said, apparently I didn't write the... So yeah, slide, spin, turn, flip, mirror. Make sure you've got some nicknames for these. And that was from yesterday's homework. But sorry. So go ahead, Michael. Okay, what one doesn't work? Monday. C does not work? Why does C not work? Oh. So Michael's saying because there's one on the one side and more than one on the... Guys, when you stand at a mirror, does your reflection look farther away from the mirror than you... No! It looks the same distance. Lucy?
D would work because honestly, how I pictured reflection, I pictured it if you hold an object and you picture those two circles that you use to control the reflection, picture those where your fingers are. How you rotate the object, I can't rotate it this way when I'm holding it like this. I have to rotate it like that. And that's how it flips the object.
Yeah, so humans are not a mirror of ourselves. Like your left side and your right side are not identical. Normally one ear is slightly off, one arm is slightly longer. But so if you put a mirror down your body vertically, it would look relatively appropriate, right? Because my left side looks close to my right side. What if I put a mirror across the middle of my body? Or what if I put a mirror at my knees? Okay, so imagine this. Imagine this. Reflection line at my knees. I reflect across that line. Tell me what I then look like.
Standing on your head.
Am I?
No, your head's not like in the
My head is now in the concrete of the building. My feet are now sticking up like probably in pain because I cannot breathe now because I am underground. And some of you are probably a lot happier that I cannot assign you any more math homework. But what other one up here also works, Kale?
Yeah, B would work.
B would also work.
Wait, okay.
You are not synced to me anymore. You can get yourself away from this slide now. If you feel like you have a relatively good handle on reflections, leave this Desmos, go into, it's still labeled 612. Guys, you have to look at what it says. 612 rotation golf. Let's go into our 612 mini golf rotation activity. So let's leave this activity. Now, if you took a long time, guys, I don't know why people keep like beginning a sentence or making a noise while I'm in the middle of a sentence. I need you to try to address that issue on your own because it gets more embarrassing and uncomfortable when I have to take it on like individually with a whole class of people. So I need you to stop because it's getting really frustrating. I'm in the middle of saying things and people are like making sound effects or turning towards a neighbor and starting a conversation. It's really frustrating. If you took forever on slide 2 or 3 on the last activity, you might need to come back to this on your own to get a bit more comfort with reflection. But I want all of us to leave that first activity, go get into the transformation golf rotation. Transformation golf rotation. And then, before we get out of here, we'll go to the final one, which puts it all together. You need to leave that first activity because I'm about to shut it down. Leave that first activity because I'm about to shut it down. Emery, get into that second activity. Or, well, it says 4th up here, but that was because yesterday's list. There we are. All right, I'm pausing the other one for now, so no one can be trying to bounce back and forth. We're just doing rotation. Now, when you go mini golf, can you just blast straight through the obstacle? No, my sister needs to learn that lesson. Because sometimes when we go mini golf, she just lines up and like, you're pointed towards the thing, and she's like, and she just hits the obstacle, and then it bounces off the course, hits a guy in the head, bounces back on the course. So here's your goal. Hold up. Here's your actual goal. When you are asked to complete these tasks, you want to try to do it in as few strokes. In golf, it's called a stroke. But here, not like stroke, like I pass out and someone needs to call 911. So, the least amount of transformations, right? So a reflection counts as 1. A rotation counts as 1, right? Like, you want to do the least amount of transformations to get from your starting point to your ending point. Let's see who can do it. Least amount of transformations. I gotta find you. Okay, I'm watching you.
So if you type in as many as you possibly can, it just spins all the way around. It looks like that.
Yeah, because you're giving it lots and lots and lots of degrees to do. But is that really helping you like complete this activity? Like, I get what you're saying, but that again is one of those things where like do that on your own time. I love that you're having fun with this, but I'm asking you to work your way through the activity. On the last one, we were waiting for you. I would like this one to be different. Hey, exactly what's happening, or has been happening, like, is evidence why we need a seating chart. Not all of us do, but some of us definitely do. So, like, it's on my list of stuff I gotta do. I need to make us a new seating chart, because some of us cannot contain ourselves near our friends.
show your sketch at?
To me, yeah, it shows your sketch. What's up?
Can I talk to you about this before I forget?
What is this?
It's 9.2.1. It's marked as missing.
Sit back down. I got it. Like, go ahead and keep working on the activity. Because I might have to log back in. But I will not let this leave my hand until I take care of it. Man, the morning class did a lot better on this slide 5, but we're about half and half right now. Like, half of us have selected everything that is correct, and half of us are still missing some things. Luca, piece of candy. Map was wrong because of me. Now, really, it goes back to you didn't have your name on it to begin with, but that's
Okay,
still
yeah.
my fault now. Yeah, and I'm gonna fix my actual grade book because that's what happened was I didn't put this in my book. Thank you.
Counterclockwise is the opposite of clockwise.
So this is
No, this is clockwise. This is counterclockwise.
Counterclockwise is the clockwise.
All right, we are all past this now. What? So, we are all past this now. What rotation will transform the pre-image onto the image? Select all that actually get us there. Eden. Some of my cards are in the wrong classes. I do not know why. Eden, tell me one of these, because we're all looking at the same slide. One of these that'll work to get us where we want to go. A? And Sam, what are you thinking?
I think C.
Now, what's wrong with B?
So B, the point isn't gonna match up. It's gonna be lower than the choice
Oh.
we want it to be.
Yeah, this is an end point, and that goes to the middle of the L? That doesn't feel right. So Eden said do C, because that goes from like end point to end point, right? And bottom. Ooh, I see Lucy's got a hand up. Lucy.
If you look at every single presumably correct answer, they're all rotating the object 180 degrees, but each point is connected to its corresponding point in the other image. So
So wait, are you saying D also works?
D also works because it is rotating 180 degrees, but it's also, if you were to take those objects and rotate them, the highlighted points that you're rotating them with would end up connecting and being in the same place.
Hey, so hear what Lucy said, and notice, so the 180 degree rotation, see how this point is directly between the two that Lucy's talking about? Like, if we drew a line connecting our pre-image image, if we drew a line connecting the pre-image to the image, if we drew a line connecting the pre-image point to the image point, that seems like it probably is not a coincidence. Keep going. That's a hint for a future slide.
I'm on that future slide.
Oh, Jesus. Jesus.
It's not loading. That is so smart. Why is my slide 7 on? Okay, wait, I got it. If you start and then it's perfect, go to the slide before and you go back. So I did that like 3
All right, I'm not going to shut down this activity, but I bet you'd have more fun if you back out of this one and go into the 612 Transformation Golf Rigid Motions. It's probably the 5th one down your list. Yeah, it's because I did that on purpose. This one is going to be a lot more fun because if you try to send your shape through an obstacle, do you think it's going to work out well or not so well? Yeah. You cannot just blast your way through obstacles.
Mr. Hudson.
Yes.
Yeah, on challenge 3 you can move the blocker.
Okay.
And you can smash it. Look, you can smash the blocker.
Well, okay. You can go through it, but can you successfully?
No.
Now remember, least amount of transformations possible. We're shooting for the least amount of transformations possible. I will tell you, I can easily do it in 4. I bet you can do it in less than 4.
Hold on.
So, just do it. Just do it for a few minutes, then we'll compare everybody. Right? Just do it.
I did it in 2.
Well, Elias says he did it in 2. Apparently he's setting that bar.
You can't do it.
I can do it in this one. But so did I.
Okay, so apparently the bar is set. So the question is, can anyone do it in 1?
No, I don't think that's. Well, if you rotate it.
Careful. Remember at the beginning of the year? Remember at the beginning of the year when I challenged you guys to balance a dozen nails on one? And a lot of you.
Yeah, it's possible.
Oh, yeah.
It's just hard.
So be careful saying things are impossible. Be careful saying that anything is impossible. My apologies. I don't think this applies to you guys unless somebody put their paper in the wrong slot up here. Because it was in 1B. But I do have a 921 that has no owner. I do need to chat with a couple people briefly. So, hey, people watching the video at home, I'm going to shut this down, but all we're going to do is talk about the results of the Desmos transformation rigid motion one. So, yeah, do those Desmoses, and then you're good to go.
Hi, Liam.
Hi, Liam.
Would you say it like that?
I don't know.